So the quotient rule is used when you have a fraction, basically. So if we've got something like x over 2x plus 5, so that would be a fraction that you could use the quotient rule for. Or it could be something like sine x over e to the 2x, so again, another fraction. Or it could be, I'm trying to find one that's a little bit different to that. So it could be one like ln x over x plus 1. Okay, so they're just basically whenever you've got a fraction, then you would go for the quotient rule. So with the quotient rule, you say that u is equal to the top of the fraction, v is equal to the bottom. So for the first one, we would say that u is equal to x, because that's the top, v is equal to 2x plus 5. So again, like the product rule, you differentiate both of those. So x differentiates to 1, and dv by dx differentiates to 2. So we're going to cross multiply like we did for the product rule. But for the quotient rule, you have to minus them for the top part of the fraction. So you would do v times this one. So you have to start with the v1 here. So 2x plus 5 times 1 is just 2x plus 5. Minus x times 2, which would just be 2x. That goes over v squared. So it would just be 2x plus 5 squared. So it always goes over v squared. So you're doing this one times this one, minus this one times this one, and then that goes over v squared. So we can just simplify that. It's quite easy, isn't it? Because you've got 2x here minus 2x here. So those are going to cancel out, and you're just left with 5 over 2x plus 5 squared. So if we do the next one, so we have got sine x over e to the 2x. So you would say u equals sine x, v equals the bottom part, so e to the 2x. Differentiate both of those, so du by dx is equal to cos x, and dv by dx is going to be equal to, so this is one really that you should know straight away, so you bring the 2 down in front and keep the power the same, so 2e to the 2x. If you weren't confident on that, if you didn't know that, you could always use the chain rule. So you could say u equals 2x, v equals e to the u, differentiate them both. So that would stay as e to the u, and then you would times those together. Now, if you've got 2e to the u and u is 2x, you would then get 2e to the 2x. So you can do it the long way, but it's just easier if you can learn that fact already. So after that, you then do the same thing as before. So we're going to do those two multiply together minus those two multiply together over v squared. So if we do this times this, you're going to get e to the 2x cos x minus, so these two times together, so it would be 2 sine x e to the 2x over v squared. So if you square v, that would then look like this. And that means that you can multiply those powers together. So actually it would make it e to the 4x on the bottom. So I was going to be a bit messy, so I'll just put it in like that. So e to the 4x would go on the bottom. So last one, I'll turn over for this. So we've got ln x over x plus 1. So you would say u is equal to ln x, v is equal to x plus 1. Differentiate both of those. So you're going to get 1 over x there. And x plus 1 differentiates to 1. So we're going to do v times du by dx. So it's going to be x plus 1 over x minus ln x times 1, so minus ln x, and then that goes over v squared, so x plus 1 squared. So the only thing that we could just do with that is a bit weird to have a fraction within a fraction. So if we times everything by the bottom of this fraction, so times everything through by x, that will just get rid of that nicely. So you'd get this bit here would just be x plus 1. Then it would be minus x ln x over x bracket x plus 1 squared, like that. What else could we do with that? Let's have a think. So you could say that that would be the same thing. To be honest, there's not really a lot you could do, but it might just be nicer to just write it like that. It just looks a little bit nicer, I don't know, to have the one at the end, but it is no different. It's exactly the same thing, to be honest.